formulate this question so that we can understand derivative for us to know its application in real-life setting. So, what is derivative? Derivative simply means a function that shows us the rate of change of a variable relative to another. Nowadays, application of mathematics, specifically derivatives, to real-life setting are being made everywhere. For example, running a business, which requires us to maximize profits, measure the rate of increase in profit relative to the quantity produced in order to create money. We can also calculate temperature variation to know which days are hot and which days are cold, estimate the measures or dimensions of an architectural work such as buildings, and find the velocity of an object or a velocity of the acceleration of the object, rate of change, and many more. I know that the concept of derivative is so broad that makes it difficult to understand. So, to make it more digestible on our young minds, I've given 2 word problems about the application of differentiation or derivative in real-life setting. So, without further ado, let us continue. The word problem 1 states that suppose that the number of people infected with a virus in a certain city is given by f of t is equals to 0.5 e raised to the power of t plus t squared in hundreds, with being t the time in days since the virus first began. How many times higher is the rate of spread of the virus on day 6 than day 2? So, step 1 is to identify the given, which is the number of people infected, and what is asked is that the rate of infected. Step 2, to solve it, we have to go back to the given, which is the number of people infected. That is, f of t is equals to 0.5 e raised to the power of t plus t squared. So step 3, and to solve for the rate of infected, we have first derivative of f of t is equals to 0.5 e raised to the power of t plus 2. And this function here will give us the rate of spread at any time t. And after that, we have to find the following ratio, which is the first derivative of f of 6 and first derivative of f of 2, which is equals to 0.5 e raised to the power of 6 plus 2 times 6 over 0.5 e raised to the power of 2 plus 2 times 2. How do we derive or how do we arrive at this ratio? Well, we are going to substitute first the variable t, which is in the power of e and after or multiplied by 2. So, if we are going to simplify that, it will arrive at the answer 28. So, the rate of the speed in day 6 is approximately 28 times higher than the rate on day 2. Word problem 2. This problem is about the application of higher order derivative. By the way, this is a physics application question. So the problem says that suppose a plane is traveling at a distance of s is equals to f of t, which is a function of time t as given by s is equals to f of t, which is equals to 8t squared minus 4t plus 23. What is the plane's velocity and what is the plane's acceleration? So step 1, we have to know the details about the problem, like plane is traveling at a distance of s, f of t, and the given, that is or which is s is equals to f of t, which is equal to 8t squared minus 4t plus 22. So step 2, and since we already know about the given, let us proceed to what is asked in the problem, which is the plane's velocity and the plane's acceleration. So step 3, before we continue, we have to define first the variables we are using. S stands for position, V for velocity, and A for acceleration. Afterwards, we have to know the relationship of position, velocity, and acceleration. So, to those who don't know yet, don't worry, I will write it down for you. Relationship of velocity and position is that V is equals to first derivative of position. And the relationship of acceleration can be linked back on the position and velocity, as acceleration is the second derivative of position, and since we know that velocity is equal to the first derivative of position, so acceleration is equal to the first derivative of velocity. Then since f of t, so we can say that here the acceleration is equals to the second derivative of f of t. So to make it easy to solve for the acceleration, we have to find first the velocity. Velocity is equal to the first derivative of s. So s is equals to 8t squared minus 4t plus 23. So by simply taking the derivative, we can find our velocity. So our velocity is 16t minus 4. Oh, by the way, how do we arrive at 16t minus 4? Well, we are going to apply the properties of the derivative in which we have the power rule. So we are going to bring forward the power of t, which is 2. So 2 times 8 is equals to 16. And t, or the power of t squared minus 1, which is t only because there is only one power. So we are going, or so the answer is 16t. And how about the 4t term? We are going, or same process, we are going to apply the properties of the derivatives, the power rule again. And so, 4 times 1, so 4. And since 1 minus 0, the power of t is 0, so the remaining term is only 4. So, for the conclusion, the answer of the first derivative of position is 16t minus 4. Step 4. To find acceleration, since we already find the first derivative, then we can just take the derivative of velocity together with acceleration. So if we take the derivative of velocity, we are going to get the acceleration. So acceleration is equal to the first derivative of velocity, which is 16. So how do we arrive at the number 16 or the answer 16? Well, we arrive at the answer 16 because the velocity of the position or the first derivative of the position is 16t minus 4. And by applying the properties of derivatives, the power rule and the constant rule, we are going to arrive at 16. So, for the answer, the plane's velocity is equal to 16t minus 4 and the plane's acceleration is 16. That will be all. I hope you learned something again. By the way, this is Mariel Juntilla telling you that the only key to overcome your fears in math is through learning to love it. Because there is no such difficulties in the things we love to do. Thank you and God bless.